Alright students, we are going to review how to calculate the area of various polygons in this video. These are all shapes that hopefully you've seen before in 4th, 5th, and 6th grade, and you should be working with formulas that you have seen before as well. We want to make sure you have a good solid foundation of calculating the area of these shapes as we move into this geometry unit. So our learning target is that by the end of this video, we will be able to calculate the area of quadrilaterals, triangles, and trapezoids. First of all, let's understand the formula, or the definition, of area. The definition of area is it is the amount of square units that are inside a figure. Okay? That's why when we label our area measurements, we label them with measurements like feet squared, or centimeters squared, or inches squared, because we're describing how many square feet or square centimeters or square inches are inside a shape. Another very important fact we need to remember is that base is always going to be perpendicular to height. Perpendicular means a 90-degree right angle. And so if you do not see a 90-degree right angle, then you cannot guarantee that it is the height. So you always want to look for what corner or what measurement is given to you with a 90-degree right angle. Okay, let's talk about our first set of polygons. First set of polygons is quadrilaterals. Okay, quadrilaterals are four-sided figures, and there's a variety of quadrilaterals that we work with. We work with rectangles, where you have two sets of congruent sides, so the top and the bottom are congruent to each other, and the two sides left and right are congruent. A square in which all four sides are congruent. A parallelogram in which is a lot like a rectangle. The top and the bottom are congruent, and the two left and right sides are congruent. And a rhombus, all four sides are congruent. Okay? The formula for all four of these types of quadrilaterals is base times height. And again, we go back to that understanding that base is perpendicular to height. And so for parallelograms and for rhombus, or rhombi, we need to make sure that we're using not the side of the shape, but we're actually using the height of the shape. The height of the shape is either on the outside, like this example, or on the inside, like this example. Okay? And notice that you'll see that little tiny square in the corner of that measurement. That's to let you know that it is perpendicular with the base. And so that's the measurement we use for height. Alright, let's talk about triangles now. Triangles are a figure with three sides. And the height of a triangle is going to be perpendicular segment from the vertex of the triangle to the line containing the opposite side. The opposite side is the base. Okay? So you'll see that the height, it can be calculated off of any vertex. So in this first example, we have the height off of this top vertex down to the base. The height can be calculated from this side vertex to the opposite side, which would be the base. Or we could use this third vertex to the base here. The same triangle can have the height measured from any of the three vertices, as long as you use its opposite side as the base. Okay? You can also see that the height can be measured on the outside of a triangle as well, just like we saw with the parallelograms and the rhombi. So that height can be on this outside right here. So the formula for area of a triangle is 1/2 base times height. Okay? 1/2 base times height, or you can say base times height divided by 2, because multiplying by 1/2 is the same as dividing by 2. So why do we divide by 2, or why do we multiply by half? Well, because we need to understand that triangles are exactly half of quadrilaterals. So we could actually piece together, if we put two triangles together, we would have a parallelogram when we put them together. Okay? That's why we know that the area of a triangle is exactly half of the quadrilateral. If you take base and you multiply by height, that's if it was a parallelogram. You then have to divide by 2 so that you're cutting it in half. Okay? Alright, let's talk about trapezoids now. Trapezoids are a special type of quadrilateral with only one pair of parallel sides as opposed to two. So we label those parallel sides base 1 and base 2. Okay? And we also have a height. That height has to again be perpendicular to the bases. And so you'll see trapezoids that look like this example, where you've got two slants in shape and the bases are opposites of each other. And you'll see examples like this example where one of the sides is straight but the other side is slanted. Again, the bases are parallel to each other, and the height is the measurement between them. How far apart are the bases? The formula that we use for area of a trapezoid is 1/2 base 1 plus base 2 times height. So we're adding the two bases together and we're multiplying by height. You can also use base 1 plus base 2 times height divided by 2 as well. That will also give you the area of a trapezoid. And you can see in both of these examples that a trapezoid is simply half of a larger quadrilateral. So you can see two trapezoids together here, okay, just one flipped going the opposite direction and put together makes a parallelogram. Same thing is happening here. If you take this same trapezoid and you flip it and put it on the other side, we have a rectangle. So that's why we're again using that same half relationship like we saw with triangles. Okay, our steps. We want to identify the parts. So we're going to label things like base and height with B's and H's. Then we're going to identify what formula we need to use and write it down. Then we're going to substitute the information in the formula of what we're given. And then we're going to solve it. Oh, and make sure you label your answers, okay, with the correct measurements. So we're going to label it with things like feet squared, inches squared, centimeters squared, etc. Okay, we want to make sure we do that for all of our answers. All right, so let's practice with some quadrilaterals. We've got all the different varieties here. We're going to start with our rhombus up here in this corner. Yes, it's a rhombus. I know you're saying, well, Miss Gordon, you have 10 miles here and 7.1 miles here. Those are two different numbers, and a rhombus has all sides of the same length. Okay, well, this is technically 10 on either of these slanted sides, but again, we want to use height, and height is calculated as the distance between the two bases. If 10 is the base, and this 10 is the base, because these are slanted, this distance is going to be less than 10. It's actually going to be 7.1. And so we're going to multiply 10 times 7.1, and remember when you're multiplying numbers and with decimals and numbers without whole numbers and numbers with decimals, we want to line up against that invisible wall, okay, and we're going to multiply through, putting our spacers, 0, 7, okay, so we've got 710, but look here, we have one number between the decimal and the wall, so we're going to move our decimal over one spot in our answer, and so our answer will be 71 miles squared. Okay? So for example number 2, we have a square. All sides are the same, so that means all sides are 3.9. So in this case, we would be doing 3.9 times 3.9. Again, we're multiplying it up against, or we're sitting it up against a wall, and we're multiplying. 9 times 9 is 81. 9 times 3, 27. 27 plus 8 is 35. Okay, bring down a 0. Cross out anything we carried. 3 times 9, 27. 3 times 3 is 10. 11, 12. I'm sorry, 3 times 3 is 9. 10, 11. That should be an 11. I apologize. Bring down our numbers. 1. 5 plus 7, 12. Carry the 1. 1 plus 3 is 4. Plus 1 is 5. Bring down our 1. We have two numbers between the wall and the decimal, so we're going to move our decimal over 2 times in our answer. So our answer would be 15.21 inches squared. Okay, now we're going to come down to example number 3. Example number 3, we've got our base of 11.3. Our height is measured down the middle. It's a perpendicular to the base, it's 9.5, so we're multiplying 11.3 times 9.5. 3 times 5 is 15, carry the 1. 5 times 1 plus 1, 6. 5 times 1, 5. We're going to cross out anything we borrowed, I'm sorry, not borrowed, carried, and we're going to Put down a place value holder and move over 1. 9 times 3, 27. Carry the 2. 9 times 1 plus 2 will be 11. Carry the 1. 9 times 1 plus 1 will be 10. Add up what we got. 5. 7 plus 6 would be 13. 1 plus 5 plus 1 would be 7. Bring down 0, bring down 1. And then I need to go back up to that wall. I need to figure out how many digits I have between the decimal and the wall. There's 1. There's 2. So I'm going to move it over 1, 2 in my answer. 107.35 millimeters squared. Okay. Last example, we have a rectangle. Base is 12.5. Height is 8. So we're going to multiply 12.5 times 8. 5 times 8 is 40. Carry the 4. 8 times 2 is 16 plus 4 is 20. Carry the 2. 8 times 1 is 8 plus 2 is 10. Bring down your 10. Again, draw that wall. There's one number between the decimal and the wall. Move your decimal over 1 time in your answer. 100 centimeters squared would be our answer. Okay? Now let's practice a triangle. Okay, first of all, we need to identify our parts. We need to identify our base and our height. Remember, base and height have to create a perpendicular relationship. Okay, so we have this height running down the middle. That height has that 90-degree corner, so we know that 3 is our H, and it's running into its base of 8. So we're going to use 8 as our B. That means the 5s on either side are not going to be used in this formula. Area equals 1/2 base times height. So we're going to replace our base with 8. We're going to replace our height with 3. And we're going to multiply. We can multiply in any order. I like to multiply my whole numbers first and then apply the 1/2 to it. So 8 times 3 is 24. And half of 24 is 12. So I know that the area of my triangle is 12 centimeters squared. Okay, last example is a trapezoid. So again, we want to identify our parts. We want to identify our bases and our heights. Okay, it's always easy to find the height first because the height has to create a 90-degree angle and connect the bases. So we see that this line right here is perpendicular. It's got that 90-degree corner. So this must be our height. It doesn't matter which we choose as our bases for base 1 and base 2, but we know that the two bases are being connected by the height. So we're just going to label 1, 1, and 1, 2. Our formula is area equals 1/2 base 1 plus base 2 times height. We're going to replace our letters with the numbers that we are given in the picture. So 1/2 times 8 plus 3 times 4. Order of operations tells us we need to simplify what's in parentheses first. So we're going to do 8 plus 3, which gives us 11. And we're going to rewrite everything else. All three of these things are being multiplied. Again, we can do it in any order. I like to multiply the whole numbers, 11 times 4 first. So half of 44, I can write it in parentheses or without, it doesn't matter. 1/2 of 44 would give me 22 feet squared as my answer. All right, you are going to do a couple problems. Okay, this first one, be really careful because it gives you the area. You have to solve for the height. Okay, so think about inverse operations on that one. And the second you try is also a challenge problem because you have to find just the area of the shaded region. I'm really excited to hear your strategies for how you got the shaded area region calculated. So work on those, try your best, and we will discuss them tomorrow in class. Thanks, guys.